Welcome to another video of capital budgeting. In this video, we look at an example of net present value method, which is another method for evaluating projects to decide whether or not they should be included in the capital budget. Assume the following cash flows for two projects. So we have been given the years, and there are two projects, project S and project L. The initial outlay for both the projects is 1000 rupees, and the cash inflows for both the projects have been provided to us. Now assume that the cash flows are occurring at the end of each year. Find out the NPV or net present value for these projects if the cost of capital is 10% for both the projects. I have been using the same example for other methods also, like payback, discounted payback, and so on. The idea is that you will be able to easily compare and contrast these methods while the data is the same. So let us first draw the time scale for both these projects. So these are the depictions of these two projects on the time scale. The outlay or the investment is shown with a negative sign because this is money coming out of our pocket, whereas the cash inflows are shown with a positive sign because this is coming into our pocket. The cost of capital is 10% for both the projects. So let us first consider project S. So as we are considering project S first, I have drawn the time scale again. Now we have to find the net present value. So basically what we have to do is first we have to find the present value of all the cash flows for the project, including the outflows and the inflows. And then we have to find the net value of all the present values of the cash flows. So basically, if we have already considered the negative sign for outflows and positive sign for the inflows, then we have to simply add all the cash flows to get the net present value. So the first step in finding the net present value is to find the present value of each cash flow, including both inflows and outflows, discounted at the project's cost of capital. So in our case, for project S, we know the cost of capital is 10%. Now, each of these cash flows has to be discounted up to this point here. So let's say this value is PV1. Similarly, here this value will be PV2 and so on. The initial investment we will consider as PV0. So here PV0 is minus 1000. So since this value is as of today, it is the present value. Now PV1 will be equal to FV1 divided by 1 plus I to the power N1. Now the future value is 500. So this is 500 divided by 1 plus I. I is the discount rate, which is 10%. So this will be 10 divided by 100, which is 0.1 to the power N1, which is 1 year. So this is 500 divided by 1.1, and this is equal to 454.55. Similarly, PV2 is equal to FV2 divided by 1 plus I to the power N2. So the future value is 400 divided by 1 plus 0.1, and this is 2. So 400 divided by 1.1 square, and this is equal to 330.58. PV3 is equal to FV3 divided by 1 plus I to the power n3. So this is 300 divided by 1 plus 0.1 to the power 3. 300 divided by 1.1 cube. So this is 225.39. And PV4 is equal to FV4 divided by 1 plus I to the power n4. So this is 100 divided by 1 plus 0.1 to the power 4. So 100 divided by 1.1 to the power 4, which is equal to 68.3. So we have found out the present value of all the cash flows. Now let's move to step number 2. So step number 2 is sum these discounted cash flows to find the net present value. So basically NPV is equal to PV0 plus PV1 plus PV2 plus PV3 plus PV4. So basically we have to sum up all these values. So this is equal to minus 1000 plus 454.55 plus 330.58 plus 225.39 plus 68.3. So this calculation comes out to be 78.82 rupees. So as we found out, the NPV for project S is 78.82 rupees. Now similarly, when we complete step 1 and step 2 for finding out NPV for project L, the NPV comes out to be 49.1 rupees. Now step number 3 says that if the NPV is positive, the project should be accepted, while if the NPV is negative, it should be rejected. This is because a positive NPV indicates that the project is profitable, while a negative NPV indicates that it is not profitable. Now, if you recall, the positive signs are given to the inflows, the cash inflows, while the negative sign is given to the cash outflow. So if the NPV is positive, then what it means is that the inflows are more than the outflows. Whereas if the outflows are more than the inflows, then the NPV is going to be negative. That means the project is not profitable. Also, if the NPV is 0, then the project does not generate any profit or loss. So basically the cash outflows are the same as the cash inflows. So it's neither generating a profit nor loss. Now, if there are two projects and only one of them can be selected, that is, they are mutually exclusive, then the one with the higher NPV should be chosen. So as we can see, in our case, both projects S and L have a positive NPV. So if possible, both projects can be accepted if they are independent of each other. However, if they are mutually exclusive and only one should be chosen, then project S should be chosen as it gives a higher net present value, and which in turn means that it is going to give us more profits. Now in this example, we use the formula present value is equal to future value divided by 1 plus I to the power n. However, we can also use the concept of present value factor and we can also use financial calculator. You can refer to these methods in the video for fundamentals of calculating present value of an uneven cash flow. There I have discussed these two methods in detail.